this video, we will discuss what is real-time operating system and why it is important for the embedded systems. Let's first understand what is RTOS. A real-time operating system is an operating system intended to serve real-time applications. So it is an operating system which is designed for real-time applications. The real-time applications are time-bound applications. It means the task must be executed within the pre-specified time. The processing must be done within some pre-specified time constraint. A key characteristic of an RTOS is the level of its consistency, concerning the amount of time it takes to accept and complete an application's task. These are some examples of real-time systems. The flight control system or airbag deployment. In these type of systems, the task must be performed in real time. It means the task must be executed within some pre-specified time limit. So for example, in a case of accident, the airbag must be deployed within some specified time constraint. So a small delay is not acceptable in these kind of events or in these kind of systems. So therefore we have to design a special or specific system, specific operating systems for embedded applications. The execution of an event or task must be completed within some pre-specified time. So for example, an event occurs at time t1 and execution is completed at time t2. So the execution time, the t2 minus t1 or delta t, must be less than or equal to some pre-specified time. For the hard real-time applications, the delay is not acceptable. In some applications, a small time delay is acceptable. The systems are called soft real-time systems. These are few examples: temperature display system in a car, sending sensor data to a server, fuel level indicator. All these are examples of soft real-time system in which a small time delay is acceptable. Now let's understand the difference between the real-time operating system and general purpose operating system. These are the general purpose operating system: Android, Windows, Mac, etc. In the GPOS, the emphasis is given on the throughput. So while designing the GPOS, the emphasis is given on the throughput. The throughput is the total number of processes that complete their execution per unit of time. So sometimes the scheduler will perform 4 or 5 low priority tasks instead of performing a high priority task. So it will execute 4 or 5 low priority tasks to increase the throughput instead of performing a high priority task. So it is designed based on the throughput, and an emphasis is given on the throughput instead of the priority. While in the real-time operating system is designed, or the scheduling is based on the priority. So the priority is more important than throughput. Execution time is deterministic, while the execution time in the GPOS is not deterministic. In RTOS, the timeliness is important instead of throughput. So the more emphasis is given on the timeliness. These are few examples of RTOS: QNX, RTLinux, VXBox, FreeRTOS. FreeRTOS is an open source operating system and we don't have to take license for the FreeRTOS.